We learned about factorials before, but let's refresh the definition of a factorial. N factorial, abbreviated with an exclamation point, is a function whose domain is the positive whole numbers. So you cannot plug in a decimal or a fraction or a negative um, or imaginary numbers. If you want to see something very similar to this, you can look up the gamma function. Regardless, we're gonna ignore the gamma function for now. We're gonna stick to factorial. It's defined recursively by there's a starting condition. 0 factorial is defined to be 1, and then n factorial is defined to be n times the factorial of the number 1 less than it. So n factorial is the same thing as n times n minus 1 factorial, and this is defined recursively as, well, it's going to be n minus 1 times the number 1 less than it factorial, and then it's going to be, etc., n times n minus 1 times n minus 2 times, this will be times n minus 3 factorial, etc. And this continues until you get all the way down to 3 times 2 times 1, and then 0 factorial is 1, so then this is what it is, multiplying n by all of the positive whole numbers less than it. Factorials get big very quickly. Here's a list of factorials. So we have 1, and then we multiply it by 1, we multiply by 2, by 3, by 4, by 5, by 6, by 7, by 8, by 9, etc. There should be a comma there. And we're into the millions by 11 factorial. Oh, sorry, by 10 factorial. We're into the billions on 13 factorial. We're into the trillions on 15 factorial. So these get really big really quickly. And you won't want to calculate these out by hand. And there is a shortcut for, typically, factorials appear in division. So when they're divided, the fastest way to simplify them without a calculator is to use the recursive definition of the largest term. So by the recursive definition, I don't mean 10 times 9 times 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1. I'm saying this is the largest term. So let's go 10 times 9 times 8 times 7 times 6 factorial. And now that's going to be really nice for us because it cancels out. Now we have 6 factorial in the numerator and 6 factorial in the denominator. These two are the same and can divide. Now we have 10 times 9 times 8 times 7 times 3 factorial over 4 factorial. Well, what's the largest term with a factorial here? 4 factorial is. So we can do this as 10 times 9 times 8 times 7 times 3 factorial over 4 factorial times 3. Sorry, that's wrong. This is, change, please. 4 times 3 factorial. And the 3 factorials can cancel, leaving us with 10 times 9 times 8 times 7. And now there's far less arithmetic to do. 8 and 4 have a common factor. And now we're doing 2 times 9 is 18 times 7. The whole denominator canceled out. So now we're just doing 18 times 7, and that you can do by hand reasonably. 126, and then times 10, 1,260. This process also works when we have variables. So look at the largest term here. 3n plus 3 is larger. And if we use the recursive definition, well, we can say that that's 3n plus 3 times each of the numbers less than it. 3n plus 2, 3n plus 1, 3n would be the next one. But let's stop there because that will cancel out with our 3n factorial in the denominator. So those two are the same. And now we get 3n plus 3, 3n plus 2, 3n plus 1. And depending on how you want your answer, you could leave it like this, or let's say you're going to be solving this as part of an equation. You might need to multiply this out, and let's do that for the fun of it. 9n squared plus 9n plus 6n plus 6 times 3n plus 1, 9n squared plus 15n plus 6 times 3n plus 1. This gives us a nice, neat cubic answer. So 27n cubed plus 9n squared plus 45n squared plus 15n plus 18n plus 6. So 27n cubed plus 54n squared plus 33n plus 6. And that is how we can divide 3n plus 3 factorial divided by 3n factorial.